What we're going to have a look at today is more on trigonometry. In a previous session we had a look at simply looking at trigonometry and Pythagoras. Now in the exams these things can get a little bit more complicated, and what we do is we have a look at three-dimensional Pythagoras. So let's go and have a look and see what goes on there. Now if we have a go at trying to draw some simple questions, we can sort of see how this works out. So let's have something fairly simple, and what we're going to do is we're going to draw out a fish tank. And my fish tank doesn't draw out terribly well. Let's see if I can zoom in here to make your life a little bit easier. So here's my fish tank. There we go. Not the most wonderful diagram that I've drawn in my life. And then we've got the rear side of this, which I'm just trying to draw in just a little fainter, so we've got an idea of what's going on. And let's imagine in this little diagram that we've got a juicy fly sitting up here, and my fish is sitting down here. And the fish, being a clever fish, knows that this aquarium, and we're going to make it a fairly big aquarium, it's going to be, let's say, 2 meters this side, and we'll have it 5 meters this side, and we can make it, oh, let's say 3 meters up. It doesn't matter really for the size. Right, so we've got some numbers, and this fish knows that it wants to travel the shortest possible line, which is going to be this line up here. But the fish wants to calculate how long it's going to take to get there, and it looks at what it's got and it can't do the calculation. It needs some help. What we've got, if we look here, we've got a rectangle at the bottom, and this rectangle, if I draw it out freehand here, is going to be 2 meters by 5 meters, and we've got the fish over this side and we've got the fly over this side, but it's vertically up here. But let's look at this distance across here. Can we calculate that? Yep, this is a right angle triangle and this is Pythagoras, so we should be able to work out everything we need to know to do this. So let's have a go at seeing if we can do this and get it working. So to work out this side, it's easy enough. This is just going to be 5 squared plus 2 squared, and we're going to work out the square root of that. So 5 5s are 25, plus 2 2s are 4, which is going to give us 29. So it's the square root of 29. And what I could do is I could get out my calculator and I could work this out. But I'm not. I'm just going to leave that as the square root of 29. And you're going to see why in a moment. Now let's have a look at what we've done. We've worked out the distance across here, and this we know is the square root of 29. We know this distance going up, it's 3 meters, and we know that this angle will meet there at 90 degrees. So we've got another triangle. We know this height is 3 meters, and we know this length is the square root of 29. So if we work out what is, I've got to work out in the end, the square root of 29 all squared plus 3 squared. Well, the square root of 29 squared is 29. Plus 3 squared, which is 9. There we are, I wasn't helping anyone, not noticing I hadn't pushed it up. Right, so if I add those together, we're going to get the square root of 38. And to work out that sum, all I've got to do is go to my calculator, and we've got to put in the square root of 38. Press the SD button, and this is going to give me the answer of 6.164, or if I'm going to do this to one decimal place, this is going to be 6.2 meters. And there is my answer. I could have done this an easier way, and it occurs to me that as we went through, we had to work this out, and we had to square root it, and then we had to square it again. Could we not do that in one go? And we can get clever with one of these. You see, if I've got my little aquarium, and yeah, we'll bring it down, we know that this little fish has got to work out what 2 is, what 5 is to square it, and then to do that. So we could do all that in one go. We could say that the distance is going to be the square root of 2 squared plus 5 squared, same as we had before, plus 3 squared. So if we work this one out, it's going to give us the square root of 4 plus the square root of 5 squared, which is 25, what gives us 29, plus 3 squared, which is 9, which gives me the square root of 38, which is the same number we had before. And so this is really a much easier way of trying to work out the distance that this fish has got to swim to get the fly. And this system works if you've got these cuboids. If we want to look at this type of system, however, with other shapes, it doesn't necessarily work quite as well. Let's see if we can do a different one. Now, if you thought my drawing of the fish tank was bad, then you haven't seen anything to when I try and draw my square base pyramid. So this is my square base pyramid, and we're going to imagine that this is going to be 8 meters, this is going to be 8 meters, and somewhere above the center point, and I've imagined that as my center point. Let's zoom in to have a look. Then I've got the different sides coming up, and depending on how you look at this pyramid, you'll see that it looks fairly awful however hard you try to look at it. Right, there we are. It's not very good, but it will do. And we'll imagine that this side is 10. Now, what I want to do is, in this question, we're told what the length of each side is, and what we need to work out is the height of the pyramid. We can't quite use the same system of trying my 3D Pythagoras, all working out in the same way. So let's work this out slightly differently. Let's look at my base. This is 8 by 8, and we can work out that distance quite easily. Yeah, that's going to be Pythagoras. But what I want to do is I want to work out this particular triangle. I need to work out the distance halfway to this center line. So what we need to do is work out where that point is on that line. I need to in fact work out then what is that distance. Let's go ahead and try and calculate that. So to work out the length of the whole line, that's going to be the square root of 8 squared plus 8 squared. So that's going to give me the square root of 64 plus 64, and that's going to give me the square root of 128. This I need to work out because I've got to halve that amount, although you'll see that it's not really quite as difficult as it looks. Let's do that. So what we've got here is simply the square root of 128, and I can leave that as 8 root 2, or might be better here to work out that this is going to be 11.313, or I could leave it as what I had on the calculator, 8 root 2. I'll show you why. If we take our 11.3 and we halve that amount, and we'll use the calculator to do this, so I'm going to take my 11.31, my answer, and I'm just going to divide that by 2. I've now got 4 root 2, or if I prefer, I can call that 5.65. And I really need all the extra digits that I can. Or we can use the surd, which is 4 root 2. The calculator's not going to mind, and this is more accurate. So I now know this distance is 4 root 2, and you see dividing 8 root 2 by 2 is quite an easy sum. We could do that in our head without having to resort to the calculator. I now want to work out how tall the pyramid is, so let's draw out that triangle. I know my base is 4 root 2. I know that my triangle side from my diagram was 10. And we need to work out what this side is, h, the height. To do this, then it's going to be Pythagoras, but we're going to need to take 4 root 2 away from the 10. So my formula for my length, I could have called that h. Let's do that. H squared is going to be the square root of, well, it's going to be h, it's just going to be, I made a mess there, let's start again. H squared is going to be 10 squared plus 4 root 2 squared. And to work out h, it's going to be the square root of 10 squared plus 4 root 2 all squared. Is it? No, it's going to be take away. We're going to take this one away from that one and we're going to work that one out. So there's our sum. Let's try that on the calculator. So I need to work out the square root of 10 squared minus 4 root 2 all squared. Yeah, that didn't work either, did it? I didn't press my calculator button. Press the arrow, that's better. And if I work this one out, I get 2 root 17. And 2 root 17 isn't really a useful answer, but that gives me 8.246, and if I do that one to 2 decimal places this time, this is going to be 8.25 to my 2 decimal places. So there's my way of trying to solve this particular problem. Working out first the base, and then we can work out the height of the pyramid. Unfortunately, people don't normally stop there. No, they usually have lovely ideas for you to try and do, and someone usually suggests, wouldn't it be nice if you could find that angle, the angle to the slope of the pyramid? Yeah, it's not really a problem. Let's go and have a look at how we would try this. So I've got my triangle. We need to work out what this angle is, angle X, and I do know that this is 10. I do know from my working out this is 4 root 2. We could use my number of 5.656 if I needed to here. It's just if I can work with surds, sometimes it's more exact. And I do actually know what this side is because I've calculated it. It's 2 root 17. I'm probably better off using the 10 because that was one of the values that's given to me, and if I'm going to have made mistakes, generally as you go through the sum you tend to make more mistakes, so let's use this one. So if we label our triangle, this is the hypotenuse. This one is next to this one. This is the adjacent, and there's my opposite. So we know from trigonometry that I've got the SOHCAHTOA, I'm working to find out an angle. If I'm working on an angle, then it's going to be the -1. I've got my hypotenuse, I've got my adjacent. So I've got my hypotenuse, an angle, and the adjacent. So this is going to be K. So I know that the cos -1 of the adjacent, which is going to be 4√2 over 10, is going to give me the angle. We'll go over to the calculator and we'll put this in. So we want cos -1, so shift cos -1 of, this is going to be 4√2 over 10. I'm going to put my bracket in and we can press the equals, and out comes my angle, 55.55. And we will call that 55.6 degrees. I've only done it to 1 decimal place. I generally challenge most students to measure an angle within a degree, so getting it to a degree in 1 decimal place is perfectly good enough here. So I can work out angles by using simply some trigonometry and some Pythagoras. So that gives us a couple of different problems that we usually need to sort of solve. Can we have something that's more difficult? Invariably, yes. So let's imagine that we've got something which is not going to be particularly nice to try and do, and this time I've got a cylinder. Let's zoom in. Right, I've got myself a cylinder, and what do we know about this cylinder? Well, let's imagine it's full of water and somebody has gone in and put in something like a stick in there, and they want to know the distance from one side to the other. So they tell us the diameter of this is going to be, let's make a number up, 12 centimeters, and let's give it a height of 15 centimeters. And what we've got to do is we've got to find the length of the rod. Easy enough. They may also ask us something really grotty, like at what angle does it make with the base. So this is the sort of going across here, and it's the angle it's going to make with that. Although it's basically a cylinder, this shouldn't really put us off, because we can sort of work out all sorts of things really with this. I've seen questions where they ask the length of the stick is something, how much of it sticks out, but with these the basic ideas are the same. So let's see what we need to try and work out. Well, it's very difficult for me to try and do some of these things, but it's not really that difficult. Although this is 3D Pythagoras, I know that this length is 12 and that height is 15. I already know most of the stuff that I need to find out, because we already know that this is 12 and this is 15. And so what appears to be quite a difficult problem is really one that's very easy to try and solve. So this is simply the length of the stick is going to be the square root of 15 squared plus 12 squared. Let's just put this into the calculator and work it out. So I've got the square root of 15 squared plus we've got 12 squared. And that didn't work nicely, did it? No, I'm having a bad day with my calculator. A 15 squared plus, you see, that's why I didn't want that one to do that way. Now I'm really bodging this up. Right, cancel. I want to do 15 squared plus 12 squared, there we are, and I'm simply going to square root the answer. It was quicker and easier. And that's going to give me 3 root 41, and that, if I press the SD button, comes out at 19.2. And I've worked out my answer. I need the angle, so this is going to be some simple trigonometry. I've got my angle, we'll call it x. We've got this side 15, this side 12. Label my sides, there's my hypotenuse. I do know what that is. That is in fact 19.2, but I'm not going to use it in case I manage to make a mistake. So I've got my SOHCAHTOA, I've got my hypotenuse, I've got my opposite and adjacent. I'm trying to find an angle, so this is going to be the tan minus 1 of the opposite over the adjacent. Probably best to put my brackets in there. And so here we go. Shift tan of 15 divided by 12 gives me an angle of 51.3 degrees. And what looked like a more difficult problem actually was something a little bit simpler. "3D Pythagoras, 3D sort of trigonometry is not normally too difficult. The hardest bits are simply when we try and work out what we're doing." Let's look at another one. Let's imagine this time that we've got a triangular prism. So my triangle, something like this, and we want to try and work out some bits and pieces. So let's give this some labels. Let's call this one A, B, C, D, E. Now I'm going to have this point down here, which I'm going to call F. There we are. I can now seal my little piece of cheese. Right, now let's see if we can work out various bits and pieces. So what nasty things are they going to ask? Well, the obvious one is getting from perhaps one corner to another. It's not really that difficult. So we can find the angle of the slope. We can find the distance across here, which is from the bottom to the top. We can find all sorts of things, and this is really not that difficult to try and work anything out. So let's have some sizes here so we can do all our work. So let's suppose we make this a piece of cheese, let's say. So let's have this as 10 centimeters, and we probably want to have at least one other. Well, let's make life difficult. Let's imagine that this is at 25 degrees. And that's all the information that I've got. Well, I hope it's enough so I can work out what's going on. It isn't. I will need to know one more bit here. I'm going to have to know this side, otherwise I'm not going to be able to work anything out. And so let's make that one 12 centimeters. Okay, now we should be able to do most things we need to do on here. Let's suppose we're asked then to work out what is the height of this piece of cheese. So we're asked to work out what is CB. We've got simply a little triangle. We've got an angle, 25, we've got 10, we can work out what is the opposite. Sokotoa, and we know we've got the hypotenuse, we've got to find the opposite, we've got the angle, so this is going to be so. So the sine is going to be the angle, the sine of 25, is going to equal the opposite, O over 10. Rearrange that, that's going to give us 10 times the sine of 25. So my height is going to be 10 times the sine of 25, which gives me 4.22. Now, I might need this number. If I'm going to need this number, then what I could do is I could store this in my calculator. I'm going to put this in memory A. I might need it later. And then I've got its full number of decimal places. So we've now got the height of my cheese. I might want to work out what is the simple length of C to E. Very easy. This is, I've got now a rectangle looking just at this particular surface. That's going to be 10 by 12. So I can use Pythagoras to work this out. It's going to be the square root of 10 squared plus 12 squared. And I can work out that CE is going to be the square root of 100 plus 144, which is the square root of 244. And I'm not very good at maths, so I'm going to cheat and do square root of 244, and that's going to come out as 2 root 61. They could ask you a nasty question where they say, give me an exact length. And if they ask for it as an exact length, then there would be your answer. If they don't ask for your exact length, then it's probably best to give it as 15.62 centimeters. If I need to work something else out, they could ask me what this angle is here. And again, we can work out this simply using trigonometry. Got my triangle. I need to find out what that angle is. Angle X. We know this is 10. We know this one is 12. And very simple now this becomes trying to work these things out. Let's do it very quickly. So I've got my hypotenuse, I've got my opposite, I've got my adjacent. This is going to be from Sokotoa. We're doing well, TOA. So this is going to be our tan. We're finding an angle, so it's going to be tan minus 1 of the opposite, which is 12 over 10. So we work this one out simply as doing tan minus 1 of 12 over 10. And gives me 50.19. .194 degrees, which is going to be rounding here 50.2 degrees. So you can see that if they give you horrible problems, you can solve them quite easily. I want to finish looking at one other nasty problem. And that is one that gives many of my students quite a hard time. And what they have, I'll try and draw this one freehand, is a carton of juice. And this carton of juice is going to be, let's say, 10 centimeters high. It's going to be some 4 centimeters wide, and it's going to be 8 centimeters that way. Not really any problem here, apart from the fact that we're told that the height of the juice is 7 centimeters. And if this carton is now turned over, we now need to work out how high it might be when we've turned it over. Let's zoom in and have a look at how we would try and solve a problem like this. Well, if I know this is 7 centimeters high, let's work out the volume. So we're going to work out the volume of juice, and this is going to be 4 times 8 times, forget the 10, it's not important here, by 7. So let's work out that. So this is going to be 8 times 4 times 7, and that gives me 224. Okay, so we know that's 224. Let's work out the dimensions of this object. Well, this is just rotated down this way, so this length of 4, this is still 4. As this goes down, this length becomes 10, and we need to work out what this one is. Well, that's really quite easy, isn't it? Because 4 by 10 is going to give me this. And what looked like a simple problem becomes really quite simple, because this is simply my 224 divided by 40, and that's going to give me a height of 5.6. Playing around in 3D, but in fact this one required nothing really very difficult about it to try and work out all sorts of nasty things, but initially it looked really quite hard. So we've got all sorts of things that we can do in 3D, playing with trig and playing with sort of other bits and pieces. 3D trig isn't really any more difficult than playing around with 2D trig. 3D Pythagoras, sometimes we can use that trick where we've got a cuboid of trying to make all the things go together. And if we get some other ones, then they're not that difficult to try and solve. We've got triangles, pyramids, we can make all sorts of shapes. They're going to come up with something new for you. They're going to chop an edge off, they're going to do something just to make your life a little bit more difficult. But basically it doesn't have to be. So with these things, break them down into small pieces. Each time just break down the problem so you can do one little bit at a time, and that way you'll manage to succeed quite well. I'll see you next time when we'll have a look at a bit more on trigonometry. Until then, if you found it good, subscribe. If you've got any questions, then just please fire them through, and I will see you next Monday. Take care. Bye bye. Wrong one. But you did it.